Okay. So in our last class, we saw that when the data is transmitted between the two devices or more than two devices, the data can be transmitted as in digital format or as in analog format. So we also saw that the techniques are some of the techniques used when the data has to be transmitted as a analog signal or as a digital signals. And we also saw that when can we use or when do we use the digital data transmission or analog data transmissions. So for today's class, let us look at the other signaling technique. So that is serial data transmissions and parallel data transmissions. So with serial data transmissions, bits are transmitted one per clock cycle across a single transmission medium, which means that the data, when it is transmitted as a bit over the transmission medium, it is transmitted one bit at a time through a single wire or channel or a single transmission medium. So in here, the sender, when it sends its data in terms of bits to the receiver, this data is sent sequentially one by one. So one by one, the bits are transmitted across this single medium or wire or cable. By sending the data sequentially, it ensures that there are no synchronization issues, meaning when the data are transmitted in terms of bit, the data is organized in specific order, meaning when the sender sends this bit, let's say the sender sends the first bit that is 0, and then second bit as 1, then 1, 0, and so on, the receiver will receive in the order that is sent by the sender. So the receiver will receive the bit, the first bit as 0, then next one 1, then 1, 0, and so on. So it ensures that there won't be any synchronization issues. So whatever the data sent in whatever order by the sender, the receiver will also receive in the same order that is sent by the sender. So sending this data sequentially is perfect for transmitting the data over the longer distance. Since there is no synchronization issues, so the data can be transferred over a longer distance. So that is one advantage. Another advantage is that the data, the serial data transmission, it is viewed as a reliable data transmission method. Meaning, when the sender sends the data bit in terms of bit, 1 by 1, 0, 1, 1, 0, in terms of bit, 1 by 1 to the receiver will also receive this data in the same order. So whenever the sender sends the data, so let's say the sender is sending the first data as 0, bit as 0, and the next bit that is 1, the sender will send this bit 1 bit, the bit 1, only if the receiver has received this first bit, that is 0 bit. So as soon as the receiver receives this first bit 0, the sender will send the next bit 1. So it ensures that when the data is transmitted or the bits are transmitted across the transmission medium, it ensures that the bits or the data is received by the receiver or the destination computer or devices. So you can rely the data transmission when the transmissions are done in serial data transmission techniques. So the sender can rely that it can trust that the data, whatever the data is transmitted, the receiver is actually receiving all the data. So that is one advantage, advantages of the serial data transmissions. So another advantage of serial data transmission is that by using the single transmission medium or the wire, it reduces the cost when it is implemented in the network. However, it also slows down the speed of the transmissions when we use the serial data transmission technique. Let us see how. Synchronization, start or stop, and error correction bits are transmitted in line with the data bits. So here, the synchronization, okay, the synchronization bit is also sent along with the actual data bit. So this synchronization bit is used to identify the bits, which bits are sent or transmitted first, or which bits are transmitted second or third or last. So by using this synchronization bit, the receiver will know that which bits are the first, second or third. So they will accordingly reorganize the bit in the order that is sent by the sender. Then another one is start or the stop bit. So this start bit ensures that that is the start of the data, and the stop bit ensures that is the ending of the data. So when it is transmitted over the transmission medium, usually it is transmitted in the form of frame. So the frame will consist of the actual data, then synchronization bit, start or stop bit, and error correction bit. So start bit, when the receiver receives the first bit, the start bit, it knows that after this bit there will be the actual data that will be transmitted. And then when it receives the stop bit, the receiver knows that, okay, that is the end of the frame or the end of the data. So immediately after this stop bit, the next bit would be the start bit of another frame or another data. So receiver can distinguish between the frame with the help of the start bit and the stop bit. Another one is error correction bit. So these error correction bit are used to identify or to make sure that there is no error or corruption of data during the transmission. So with the help of this error correction bit, which is embedded with the data, so when the receiver receives, it will recalculate its own error correction and then compare with the error correction that is embedded with the data in the frame. And then if this error correction embedded in the data or the frame is same with the error correction bit that is calculated by the receiver, then it is assumed that the data is correct or the data received is correct without any error. So this is the use of the error correction bit. So this synchronization bit, start or the stop bit, and error correction bit are also transmitted along with the data bit, one bit at a time, one by one. It is transmitted across the single transmission medium. So because of that one, it limits the overall throughput of the data, meaning it slows down the speed of the data. So when you say throughput, it measures the actual data transfer per second. So because of all these bits transmitting all together, it even slows down. It slows down the speed of the transmissions. That is the disadvantage in serial data transmissions. So these serial data transmissions, when it is transmitted over the transmission medium, it uses either synchronous or asynchronous technique. So in terms of asynchronous, so in asynchronous transmission, it uses special bit, that is start or the stop bit, So these bits are inserted with the data, actual data or byte, so which helps the receiver to distinguish. By looking at this start and stop bit, the receiver will know that that is the ending of the byte or frame or starting of the byte. So it helps in distinguishing between the frames or byte. Another one is synchronous. So in synchronous transmissions, the byte or the data are transmitted in with the standard time interval, meaning when the data are transmitted, the sender and the receiver, both of the device uses or follows the standard time interval to distinguish between the frame or byte. So maybe, for example, the sender sends the data or byte after every 2 nanoseconds. And then let's say 2 nanosecond is the standard time interval. The receiver will also receive or make sure or distinguish the data. So after every 2 nanosecond, if the receiver receives the data, it will assume that, okay, the first bit received, okay, then after 2 nanosecond, it will wait 2 nanosecond, then next bit received will be considered as the another byte or another data by the receiver. So receiver will assume that every byte, the receiver will assume that one byte is transmitted every interval. That is the standard time interval, that is both followed by both the sender and the receiver. But by when you say the sender and receiver follows the same standard time, sometimes the sender, if the sender and the receiver is not synchronized, meaning if they don't follow the same standard time, then it can affect the accuracy of the data. So let's say the sender uses 2 nanosecond as the time interval, and then the receiver uses the 3 nanosecond as the time interval. Then the data received by the receiver can be assumed differently compared to the data sent by the sender. So it is very important in terms of synchronized transmission. Both the devices should follow or should be synced to the time interval. It should follow the same time interval. So we can see that the data accuracy is highly dependent on the timing being synced correctly between the devices, which means that the sender and receiver should correctly synchronize their time intervals so that the data delivered or the data received by the receiver is correctly assumed or correctly interpreted by the receiver. So these serial data transmissions are usually used when the data has to be transferred over the medium or long range. So usually you can find that serial data transmissions are used when the data are transferred over a longer distance. Not only the medium to long range transfer, the serial data transmissions are also used when the data has to be transmitted, when the amount of data transmitted is relatively small. Then then you can use the serial data transmissions. So when the data is relatively small amount, and when you have to transfer the data over a longer distance or long range or medium range transfer, then serial data transmissions are used. So these serial data transmissions are usually used when you have to connect to the system, when you have to make connection to the system like your PC or desktop and other devices. So example, your USB cable, that is the one, the image here, universal serial bus. So you can use this USB cable to connect maybe a phone to your device or your PC computer. Then this cable can be used, which transfers the data one bit at a time, or it is or the data is transferred in serially manner or in sequential manner. You can also find the serial data transmission when you connect your keyboard with the your computer or PC. Another example can be mouse, when you use mouse. So all these the connections uses the or it uses the serial data transmissions. So serial data transmissions are implemented in all of these connections.